This is the video for class 11th, and the topic which we are starting today is friction and its types. So this is the topic which comes under the chapter that is laws of motion. So starting with the friction, we all know that what is friction. Friction is an opposing force when the two bodies comes into the contact for a relative motion over each other. When we talk about the solid bodies coming in contact with each other, that time the friction plays the role which opposes the motion of the two solid bodies. But when the same thing we talk about in the form of fluid, in the form of liquid, when the two layers of a liquid or when the two layers of fluid basically comes into the contact with each other and they tries to flow over each other, so that time the opposing force which plays its role is called as viscosity. So the same force, friction and viscosity plays the same role, that is opposes the relative motion of the two layers or the two bodies which are in contact with each other. So when it comes to as the types of the friction, so basically the friction is categorized in external and internal friction. When we talk about external friction, means which arises when the two bodies in contact with each other try to move, or there is an actual relative motion between the two. So that external friction is called as contact friction. And I have written in front of you, I have written the contact friction, that is static, limitic and kinetic. And after that, kinetic is termed out or differentiated in two more parts, that are sliding and rolling friction. But when I talk about internal friction, that is the external opposite of external friction, so which arises on an account of relative motion between every two layers of a liquid, or we can say fluid. So internal friction is also referred to as viscosity, which I was talking about in the beginning of the topic. So now let us start with the static friction. Let us imagine what it is there. Suppose a box or a mass body is capped over a fixed surface. Okay, suppose let us take a table here. And what is happening, if suppose let us consider a block of weight mg, means if suppose I will talk about the weight always uh, happens in the downward direction. So if suppose this is a weight which is acting in the downward direction mg, lying on a horizontal surface, or we can say a table. So when a body presses against a surface, okay, the surface deforms and if it appears to be rigid, so the deformed surface pushes on the body with a normal force, that is a reaction. In terms of reaction, if I was talking about, that is r. When a body is in the state of rest, then the two forces are acting each other equal and opposite. One is weight which is acting downward, and another one the reaction that body is getting because of from that surface. So basically when the system is in the position of rest, that time our reaction is equals to mg, that we have studied already in this chapter. Now from where this friction is playing its role. Now suppose what I will do, I will suppose a small amount of force is applied on the block to the right, means if suppose I will apply a small amount of force, okay, and the what is the direction of the attempted force, the direction is in the right side, and I am naming this force suppose from p. It is a small amount of force. Now we know from the experience a small applied force may not be able to move the body practically. If I will apply so small force, okay, it may not be possible, or may be possible my body will not gonna move. Why this body is not gonna move practically? Because a body remains at rest because there is some other force F is also present in the horizontal direction but in the opposite to the P, and resulting the net zero action of this force, means this weight is balanced by the normal reaction in the upward and downward reaction. But if suppose I am applying the external force in the right hand side or right side of the direction, but this box is not moving because might be possible some force is also present over here which is opposing the relative motion of this box or this block over the table. So this force is opposed by some other force which is present between the contact of a block and a table, and this force is called as frictional force. And which type of friction, if suppose various type of friction I have written, so which among them, which of the this friction is playing its role, means which of the friction is playing its role. So for that I need to say, as long as box does not move, means if this is condition happening, means still the box is not, or the block is not moving over the table, means till then our F will be equals to P. I can say that if F will be equals to P, our block is not gonna move over the table. So means the opposing force that comes into the play when one body tends to move over the surface of another, but the actual motion has not yet started, so that type of friction is called as static friction. Means whatever the case I am discussing for the static friction, means this type of friction is called as static. Means when the whole system is in the position of rest, or if we are started, if we are applying the force and then also the object has not started movement, so means in that condition which force is playing its role, that is static friction. Always remember, the static friction does not exist by itself. When there is no applied force, there is no static friction. It comes into the play the moment there is an applied force. It is not like the object is in the position of rest. Okay, if suppose there is no P, so there will be no F as well. Okay, there will be only two types of forces, that is R and W. And if suppose we are applying P and still the object is not moving, then in that condition only our static friction will comes into the play. So that is the role of static friction. Okay, the static friction always opposes the impending motion. The term impending means what? The term impending motion means motion that would take place under the applied force if friction was absent. The impending motion does not actually take place. हुआ नहीं है friction तब तक, just it is actually means we are trying to move an object but it is not happening. We can say that the maximum value of the static friction, when what will be the if suppose now what I will do, I will increase the amount of the force. Okay, this P, the magnitude of the P value I will gonna increase the moment the block will gonna start. The moment, okay, till before the moment the object is gonna start, till before the friction will be at its peak, means that static friction will be having its maximum value till the motion of the object has started. So the maximum value of the static friction can also be called as limiting friction. That is the second friction I am talking about. Now it's basically, if I will explain what is limiting friction, so limiting friction is the maximum opposing force that comes into the play when one body is just at the verge of moving over the surface of the other. Means when the body is about to move, means I will increase the magnitude of the P, magnitude of the external force, and till then the just when the block is just at the edge of the movement, at that time the maximum value of the friction can be called as the limiting friction. Okay, so when we increase the applied force slightly beyond the limiting friction, the actual motion starts. Means if I will increase slightly more magnitude of the P, our motion will gonna start. So this does not mean the friction has disappeared. It only means that the applied force is now greater than the force of limiting friction. Means the magnitude of the force is greater than the static, as well as it is greater than the limiting friction. The force of friction at this stage is called as kinetic. Now which I am talking about kinetic friction. Means at this stage when the object has started its motion but still the friction is there. Okay, so that time it is not like the friction has reduced or the friction has vanished. The friction never vanishes. Okay, so it is just like the friction the value of the frictional force or the external force which I was applying, it is greater than limiting, it is greater than the static. So now the friction which is playing its role is called as kinetic friction. Now basically, if I will define what is kinetic friction, so dynamic friction is the opposing force that comes into the play when one body is actually moving over the surface of the another body. So it is found that the force of kinetic friction depends on the normal reaction and the quality of the finishing of rubbing surface. It is like a kinetic friction depends on these all factors. So it does not depend on the area of contact. Always remember, we are having one old age view that if we are increasing the area of contact between the two surfaces, so the force of friction also increases. It is not like the force of friction never depends on the area of contact, because there is one another term, that is adhesive pressure or adhesive force. You can study about adhesive force and area of contact in detail, okay, in the next lecture, or in the book. You can go through the book as well, it is written over there. So always remember, It does not depend on the area of contact, but the kinetic friction does depend, though to a small degree, on the velocity of the relative motion of the bodies. Okay, if I will draw, suppose if I will draw the relation between the applied force and the force of friction, if I will draw the graph between these three frictions and the applied forces, so what will be the graph? So always remember, if suppose here is applied, this is here is applied force, and here is friction. Suppose if I will write friction here, so what will happen, where how the graph will gonna look like? Slowly when we are increasing the applied force, our friction increases like this, and after reaching at a peak point, our friction comes and our friction becomes constant during the motion. So if I will segregate these things, okay, so how I will gonna segregate? Always remember, static friction gradually increases with the increase in the force. So this line, this area of the slope can be written as Fs, that is static friction. And this area, that achieving a height, that is achieving the maximum value of the static friction, that can be, it can be written as Fl, that is limiting friction. And after that, the friction becomes constant with the relative motion, that is Fk. But one line I said, the for the small degree, means for the small degree, if I will talk about, so the velocity of the relative motion of the bodies affects the kinetic friction. But if you will see the graph of all the three frictions, so I have drawn the graph, and I have drawn the relationship with the applied force, so you can go through them. Okay, and always remember one thing which is in the keynote, that kinetic friction is always slightly less than the limiting friction. Always remember this point, these type of question usually comes. Okay, the limiting friction is always slightly greater than the kinetic friction. Thank you.